And we are live. Okay. Hello, welcome. If you're not familiar with what we're doing here is Advent of Code. Please see the previous two videos if you haven't seen them already. I'm basically learning Rust while trying to solve coding problems, and we're gonna have fun. I'm usually wasting a lot more time than like experienced coders because I'm doing this in a very, let's call it educational manner, where I basically try to like learn the ins and outs of something and not like get to a solution fast, but get to a high quality solution or something that I kind of at least feel okay with, um, that will satisfy the problem and also will actually teach me something new. Without further ado, let's open the Advent of Code website. We are now in day 3. And there's going to be some text, and after that, some kind of riddle, and we will try to parse that and make a solution. Um, so, you and the elf eventually reach a gondola lift station. He says the gondola lift will take you up into the water source, but this is is as far as he can bring you. You go inside. Doesn't take too long to find the gondolas, but there seems to be one problem. They're not moving. You turn around and see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It will still be a while before I can fix it. You offer to help. The engineer explains that engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are a lot of numbers and symbols you really don't understand, but apparently any number adjacent to a symbol, even diagonally, is a part number, and should be included in your sum. Periods don't count as a symbol. Here's an example engine schematic. So 467 dot dot blah 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 blah. In the schematics, the two numbers are not part numbers because they are not adjacent to any symbol. 114 top right and 58. Every other number is adjacent to a symbol, and so is a part number. The sum 4361. Okay, so the sum would be just okay. So everything that's adjacent to a symbol. So this one is adjacent because it's diagonal. This one is as well. Okay, so everything except for 58. Okay, so we need to find the neighborhood of things. Okay. What is the sum of all part numbers in this engine schematic? Okay, this is seems like quite a terrible thing to do in Rust, but sure, we'll give it a go. So basically, we've got a grid. So we have something like that, and every time we've got some kind of symbol, then every number adjacent to that is going to be considered a part number. But this number right here, but 55 isn't because it's not adjacent to any symbol. If I understand correctly, let's read that again. Or do numbers that are adjacent to other numbers also count? No, so only numbers that are adjacent to symbols. They have also not included, I think, by design, any examples of adjacent numbers up or bottom. Okay. So we need to scan everything, and then everything that's adjacent to a symbol, we need to somehow like count it up. We need to tag it with something. So I think what we can do is we can like flood everything. That means that for every symbol like that, we basically flip a bit on all the adjacent rows so we can color them with something. Use some kind of color, yeah. So everything that's around a symbol, we can basically color like that. And then we can bit mask. We can basically multiply by 0 everything else. And, or I mean, multiply by none or something like that. Then only scan the things that are left and do the thing. Sounds, I think, reasonable. The time complexity of this would be bad. Good, let's think about that. We will need to do an initial scan, find all the dots. And for each one of them, we need to do this grid, which is just O of the amount of dots, which is okay. Still like a pointwise scan. And after that, we need to scan and basically we need to pass every number and ask whether a digit of it, of the number is actually like lands within a green square. So 2 scans, one for marking, one for actually passing and doing the thing. Seems reasonable, I think. So maybe let's just get on with it. So we can duplicate a previous day just so we will have a nice scaffolding. And we need in our solutions. Oh, I haven't committed yesterday's answers apparently. So let's just do that quickly before we actually move on. So let's add everything except for day 3 and day 3 and day 3. That's going to be day 2, P2 solution working, commit and push. That means that also people from yesterday haven't seen that. Okay, login via GitHub. Okay, let's just do that quickly. And we're pushed, and let's move on. Okay, we need day 3 part 1 solution, and later on we'll do day 3 part 2. So day 3 part 1. This one is not working because we need to also match against this. Yep. Why is this not working? Mod. Why is day 3 not showing up? Do we need to do anything fancy to make this work? No. Main RS. What? Mod part 1. Let's just mod part 1. And it says attached to main. Oh, apparently, okay. So this is the place where I missed it. Okay. So this should just autocomplete fine now. And we can start with emptying out the solution. Start working on our own thing. So so first of all, we've got like the full game, the full board, which is this one. Let's just add that to our test. And yeah, this is going to be third equal run on this input string. This needs to be exactly that. But this, of course, won't do because, well, don't have anything yet. And why is this? This needs to be, yeah, we need to unwrap that. Yeah, okay. So this is our like total like full game assertion. And now let's actually figure out how do we tackle this. So we've got two things, which is the symbol map and we've got the numbers map. We need to basically unwind that into either a 2D grid. Yeah, I think a 2D grid is like a good way to model that because it is a 2D grid, but we also want to maybe like look it up easily. So how would we do this in a sane manner? Because we also need to like obviously count for the edge cases where the symbol is, I mean, on the edge, basically. By the way, how does the puzzle input looks like? Okay, it is huge. Okay, so let's figure this out. So first of all, we need some kind of struct of sure. Yeah, the size char seems okay. No players, no scores, no moves, no. And that's going to be test schematics, not game. And in each vec, we will basically have an enum, not just a regular chart. So we've got an enum which will be either so yeah, might be either empty, might be an a U8. Oh, but yeah, U8 number, call that number, and that's going to be a U8, or it's going to be a symbol, which is going to be just any kind of char. That's not a dot, basically. So that's going to be a point. That's going to be a vector of points. And we can, first of all, pass everything into that state. And then we can try to figure out everything else. So let's do that. So let's write our own parser for this. Function pass is going to take an input of string reference, definitely not this thing. That's going to be an iResult of third and bold. So yeah, instead of game, let's call that schematic. So that's going to be our grid. And that's definitely not a to-do. We actually need to do this. So how would we actually flatten this in? We could say something, so that's going to be pass schematic. So fold many is definitely the right thing. Let's do that quickly. So first of all, let input be trim. Okay, trim is actually a good thing to start with because we don't want any extraneous empty lines to annoy us. This will surely be better now. Okay, so we've got our trimmed input and let grid. Fold many is actually the thing. Let's import that. And our grid, we want that to be an actual, well, not grid, but let's just initialize the full game. So, oh, you know what? Actually, yeah, let's have that as this is going to be a tuple of string reference and vec of point. So we've got our vec new, and within it we are going to do a lot of magic. So let's actually look at that. We do want an alternating pattern from GNOME, which is basically we either consume we consume basically a predetermined set of things. So let's actually do that. So we've got, is map the right thing? Yeah, probably. So if it's a digit, it is a number. We could just use map pass, right? So we do have we do have just pass. I already have a reference for that somewhere in this day. So pass, pass. Yeah. So stir parse. Yeah, that's the one. So yeah, map digit one pass. Where is it? Oh, wrong day. Yeah. So map digit pass. And does this return? This returns a result. So we need to somehow unwrap that. Okay, so I see why why Copilot did the thing where it basically passes and unwraps, because we want to we are guaranteed this is a digit, so we will be okay with that. So yeah, map, not digit, but actually tag dot empty and missing tag, basically anything else. Can we say is not like else? Is there like from the branch self alt permutation needs to be a list? What's the way to use alt exactly? So alt parser alt blah blah alt blah blah. If you need more, it is possible to nest other alts. Test a list of parsers one by one until one succeeds. So, oh, so that means we need to, do we need to basically alt everything again? Not sure. This function takes one parameter, but two are supplied. How do we use alt? Branch. Yeah, that's the one that I didn't want to use because the same docs as whatever that was. Nom alt GitHub pages. Nom Passing with none. Okay, so Alt. We've got tag or. Is that a thing? Is that actual syntax, or is it like magic? This feels like it's not exactly the actual yeah. Let's find alt maybe in this. Also is written with none. A guide to using none. Oh, that might be useful. Let's look for the word alt here. So alternatives and composition. Okay, so we need to pass it a tuple. Okay, so we are just missing one more set of parentheses. Now we can pass it whatever we want, which is this is empty, and basically we need to say anything. So how do we say I want like a case for whatever leftover, basically. So this is going to be a symbol, or do we want to actually enumerate these symbols? You know what? Let's actually enumerate these. So it might be maybe any char. Is any char a thing? So any char is already a parser. Basically just advances by exactly one, matches one byte as a character. Note that this that the input type will accept string, but not ref u8. Okay, that's okay. I don't care about that. Complete version will return an error if there's not enough input data. Okay, so any char, that's going to be a symbol. And we don't care about which symbol it is. So yeah, we remove that thing. And we've got ourselves a complete description of the board now. Just need to basically, yeah, so we are folding everything. This always advances by exactly one digit. Is this more than one digit? Let's just make sure this is actually taking exactly one. Recognize one or more ASCII numerical characters. Complete version will return an error if there's not enough input data. I want digit 0 or more. I want exactly one. Oh, I think we might. Okay, I think it's okay because it will basically it will recognize one or more digits. It will error out if there are no more digits, but we need to map that over an input to actually pass a full integer. That will take exactly one. So yeah, I think we'll be okay with whatever it is right now. So yeah, back to the passing code. So this should give us a grid. And does this grid actually work? We just need to return this input, basically. So OK schematic grid. So let's test our passing. So before we actually do this, let's test schematic parser. Once we have got our schematic parsing working, we don't need to worry about string manipulation anymore, when we can only work with in the symbolic world. So schematic. So yeah, let's just assert that pass schematic of. First, let's just do simple stuff. So this should return a OK schematic empty. Yeah, seems reasonable. Let's do this with one. That's going to be exactly number 1, and we want a symbol. So let's replace this with a star. Oh, but yeah, okay. So this is still in the raw world where we don't specify which one is actually like adjacent to another one. But basically, yeah. Anyhow, and here we've got a symbol. So let's run this and see the test fail. It says that it's unhappy because it's running what? Why is it running a test from the previous day? Ask you to run this one. Only this one. It says cube count. What? Why are we why is this not compiling? Mismatch types. Found the cube count. What the hell? Let's just literally comment these out. I don't care about these tests anymore. I mean, they're unrelated. What the hell is going on? Fold many. Okay, we are only within now the actual. We are actually debugging the right compilers. So it says expected function mute, but something. Okay, this needed to be, yeah, this needs to return something that could be made into a mutable thing. Let's rerun that. It says partial equality missing on schematic. Why do we need partial equality? Because we are asserting something. So let's derive debug and show clone. We don't actually need clone. We do need quality, partial equality, and ordering. No ordering. And we need to apply this fix. Sure. And it says the trait equal is not defined on grid. So partial equality then apparently must implement partial equality. So yeah, let's actually implement equality. So derive. Okay. So our schematic parser is now erroring out because we are giving it something and it is unhappy about it. And as I've seen with the many zero example, basically meaning if we see the many zero code, that means we are not actually consuming our input. This is a bitter lesson from yesterday. So let's actually look within this many zero fold many zero implementation and figure out what's going on. So we need to somehow know when to quit the first row and actually start working on the second one. So how do we do this? So this is not any char. This is not white space. Is not \n. And that's our thing, basically. And that will basically let us go one level lower in the grid. And it says now that required by bound. Wait, find token not implemented for char. Oh, sorry. Apparently, chars are not good enough for this parser. And it says we are still airing out, still on many zero. Okay, so Oh, firstly, we need to unwrap these, and then we will just crash harder, but dot unwrap. And now this would panic before we actually get into our comparison, which is okay. So we won't also need these assertions, the OK wrappers. And let's go to this parser. So fold many is going to accept exactly. So first of all, it needs to be many 1, I think, because we are expecting at least 1, right? Let's actually verify that. So repeat the embedded parser calling G to gather the result. This stops on error if the last there's at least 1 result. Instead chain an error up. To insert chain an error up, C cut. Okay, so interesting. What is actually cut? We don't need to chain an error up, but basically, if the parser passed to many1 accepts the empty inputs like alpha 0 digit 0, many1 will return an error. Okay, so yeah, this is a big problem. So we need to basically say we don't accept empty inputs. And let's actually look at that. What we've got an empty string and a schematic. And the schematic is a bit different. So we are not erroring out, which is good. And now we can actually do this. So we need to do this map parser, which is take until new line. Then we are going to give it the old parser. And this one is going to be any char. Are we doing? We are erring out because we are panicking where? We are panicking somewhere. Bring this up. So we are unwrapping and we have errors, which means that I fucked up somewhere here. So we might not want to take until, so let's just not do this also right now. So this will take any char, which is not good, because we do need to stop at some point. Oh, so now the parser works. I mean, it's now passing exactly 1 row. That means we are not actually linearizing anything. So unused import map parser. Yeah, okay. So I have a crazy idea. Let's keep this parser a little bit cleaner now and linearize later, and like shuffle the vector later. So let's actually remove 1 layer of fold many because we don't need it. We do want input trim. So let's apply that right here. Wait, yeah, alt parser. Do we have a syntax error? Type mismatch. It says vec. Oh, yeah, we do have exactly 1 vector points. And let's actually return this correctly. So this is going to be not yet the schematic. This is just our serial grid. So we've got that. And in order to make that, to fold that into our grid, we need to actually fold it. So let's look at that. We need to basically have another view. So that might be a good time to actually test that. We do need to know what is the length of this thing. So let grid width be input lines next wrap length. Okay, sure. Seems like a way to do this. And in order to fold that into a grid, we can apparently chunk things. Ooh, that is nice. Row to vec, collect. Okay, so iteration in Rust is really, really, really friendly. Let's run that. And we will need a clone list. Wait. So point derive clone. Do we want to clone? Yeah, we do. Of course we do. We don't want to think about that right now. We just want. Okay, so our unit tests are now sort of working. Let's do multi-line. So we've got \n and now ... And that is going to be another set of empty vectors. And let's rerun that, and it now fails on. Apparently I put one too many, or no, I see. It converts a new line. So is not new line. So how do we basically skip that? Yeah, is not new line. And that will error out. So we need to filter out. Okay, so we've got a new line. Let's just do that quickly. And we've got map tag new line. Awesome. And here we've got really nice chunks here. But before we actually chunk that, we need to filter on e yeah. So yeah, p new line is going to do the thing where we borrow it once. Not sure if that works. It says no implementation. So yeah, we definitely want to just borrow. Is that okay? It says can't compare point with this. Why is that? Because it said we need to probably do something like point new line. No. No method for chunks or struct filter. So collect chunks. Collect. Let's apply this. Okay, so we are iterating over everything. We are filtering out, oh, first of all, not new line. We do want this to be borrowed, I think. I hope this will work. We need to collect that into a temporary vector because we want this to work. I see that this is a global allocator or something. Yeah, allocator API. That's very nice to see that. And we need a vector of points, not a vector of point reference. And that should do it. And it says, implementation support that. And then it says a lot of crap. I just want things to work. Why is filtering by new line is not a thing? And compare ref point to point. And if we add a ref here, would that be better? Ref also here. Okay, so iterator item. Okay, this is a borrowing operation, and we are filtering, and we need to collect that. Why is this not collecting? Collect required by a bound introduced by this call vec point. Could we make this into a ref? No, that won't do anything good for us, right? Iterator item changed to vec ref point here in map row. So this chunks thing is thing that's complaining? No. Okay, this expression has type vec point. That is correct. And then we are iterating it, and iterator item is ref point. We can map that into clone because cloning things around just solves problems. And then, except for the unused import, we are panicking where? We are unwrapping on incomplete size. Test schematic parser. We've got our pipeline here. Let's debug what we've got in this grid. So dbg grid. And where's our debug info? We're seeing an incomplete something. Okay, so we are not even getting into actually debugging this. So where's the panic coming from? It says unwrap on error. Incomplete size. Where's our unwrap? Okay, so firstly, let's do this. And okay, so we basically want to tag new lines before everything else. And we don't want to unwrap here. Maybe we do. I don't know. Let's think about that. So digit 1 is going to, we have to consume something, which means this will either succeed or fail, and then, oh, but we don't want that to like silently succeed and not consume anything. Um, how can we help that work? Let's just maybe we can do use map response, and let's hope this parser is like okay with that. So digit, then string pass. Was it not string pass? Not map res. Just we can import that, but str pass. Okay, so that will maybe fail. And it will now complain about, it says the trait from stir isn't not implemented for point. Why does it need to see point? Not a point. Oh, wait. I see. We are missing the whole map. Wait, so this now actually does like exactly like this is the thing where we consume too many characters. So we maybe just need digit 1, basically. I think digit 1 is the thing, because we want digit 1. Oh, but we want to convert that into a number. So we want to map digit 1 onto this thing, but we don't want this to fail, because if it's an empty thing, then we need to throw an error. So how would we do that cleanly? We can do something like, instead of unwrapping, let's question mark this, and that would bubble up the error. Not in a panic way, but just that would do the thing. So can only be used in closure that returns a result or option. Another type from residual. And why does that not return? Because, well, okay, so we can try and do this. Figure this out. So we've got maybe map response. No. Maybe we want to do something like just not digit 1, but is digit, basically. So yeah, let's map is digit, then see point and wrap digit thing. Yeah, seems way more reasonable now that we're consuming exactly 1 digit. And that means that empty inputs now won't fail. And this one is complaining that expected U8 found ref stir. Why did it expect U8? Because of this thing? So let's do this where we say C, which is ref stir, and we pass it in. Would this satisfy you? No. Are we taking this from the wrong place? This should be bytes? No. Complete is char U8. So this thing needs to somehow we need this to be ref, and now it will complain this spot where basically first bytes first. is unhappy with me. Charles. Why is passing digits always a pain in the ass? I just want the thing like one digit and just not to unwrap. Maybe we want to map a parser. And that way we are going to be able to safely unwrap that, maybe? No. This is still not going to work, of course, but we'll get there. So pass one digit, and that will return a result of exactly this. So C. Pres let input maybe digit equal to any child input, then if is digit has U8 in that, we don't. Yeah. And return here str pass maybe digit. And does this not exist? It does. So what is it happy about? It says found error. Oh, that's really, really good to know that there's like from error kind. Okay, that's so num error from error kind input kind. Parser. Okay, that's the one. So let's try parser. Okay, so we are now consuming exactly one digit. And we are unwrapping that. If there's no characters anymore, then this will error out for us. We don't need to do anything about that. And we pass exactly one. If it is a digit, then we are returning it. Otherwise, no. And now we can map this here. Our function would now not be called if there's not one, there isn't any digit. So yeah. So let's try to run that. It says this digit is unhappy as Q8. Expected stir found ref char. The trade parcel O is not implemented for result. So apparently not the way to go. So how can we return this result correctly? So this one, we need to return an error. Okay, seems like it might do the trick. No, it doesn't. So we need the other way around, maybe? Wait. This is, we need to return error. This is the num error. Yeah, okay. So we need to return a num error. And within that, we need this, maybe. Why can't I say like something? I just want this to work. Okay, it is not a digit. Wait, is this? This is a bool, so this is not good enough to actually apply as a. Oh, I know what we can do. We can do this. We can say digit 1 input, and this is it, right? Digit 1 is going to return so let input be not input, yeah, input and digit. That's going to be exactly one digit, and we can now return OK on pass. Yeah, would this work? It says from pass int error not implemented for non-error ref string. God damn it. That's quite unfortunate. Let's unwrap that. Now that this is exactly one digit. So pass one digit now returns either this or that. Let's just move forward. Growing impatient. So this one we can also unwrap now because we are passing exactly one. And it says that pass one digit ref string is not correct here. That's a U8 already. That's very nice. So this is going to be a number now. Okay, so where are we now panicking? It says incomplete size 1. So incomplete size 1 is thing. Um, Incomplete is one. Passing an integer always results in incomplete. Okay, so it's still from passing an integer. As of node 511, approaches toward combining parcels changed macro-based functions from macro-based to function-based. Widely discussed. So map res recognize pass input my U64. So my num42 default, yeah, that's not what I want though. I want just the one. So would this, so do we need to recognize one digit and that's the way to do this? Instead of like moving it on? So let's try that. Recognize one digit, and that's it's going to be now S, and that's going to be string pass unwrap, and the pass this, and would this please be working? Test schematic panicked 969. So but which line actually panicked? Okay, let's just debug. So let's what? So result unwrap called with blah 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 blah. Okay, so this unwrapping is called not incorrectly. Okay, where are we? Pass schematic. Where's our error happening? So let's unwrap here, and that would give us a very nice clue of, well, are we panicking? Are panicking on something. So fold many types must be known at this point. Oh, interesting. Wires bound. So recognize digit one. Let's add a register here. Would this be helpful? Not enough. It says digit register E. Why can't it fucking infer this? So this pass result is Actually, you know what? Let's just do this. We're going to be anyhow result, and that's going to be this thing, and this is going to be unhappy because we haven't declared anything. And this one says okay. Grab okay from expression. Expected stir, found stir schematic. Why is it expecting stir? Our schematic is, oh, yeah. So now let's find that here and also here. Ref stir says nom parser error. Consider restricting type parameter e. Okay, so let's consider the thing that they say. And it says for a reference without explicit lifetime cannot be named here. So this string reference is going to be ref pick a string reference, right? No, sorry. E for lifetime a. Wild for unwrap. So plus okay, so this is very nice of like the debugger for actually the compiler to actually like say what do I need to do to change to make things work. But also like this is terribly terrible. Apply fix, please. I mean, requires bound. Type annotation needed. Cannot infer type of type parameter e. So why is this like so terribly terrible? This is obviously not what I wanted. This is just going to be, let's try that. Okay, so let's actually copy that thing from here. We've got all of this crap. Instead of like having this into the generic declaration of this function, let's just put it right here. And it will now say trait must include line object. We don't have a lifetime here. What we do is have a string reference. Let's remove this fmt debug. Parser cannot be made into an object. Trait object must include line keyword. Trait, can we box this and might work? And it says now that Trait box line trait is not satisfied. Oh my god. Why does unwrapping make life so hard? I mean, it is good. It is shaming me for writing bad code, but I mean, I just want to get things done. Can we please just make things work? That was an I result. Yeah, so we've got that. And instead of this, I want to unwrap this somehow. How can I unwrap that? I want to basically take all of this. This is going to be some result. Now our result, before we unwrap it, please just compile. It says which moves. Okay, so let's just do this. Ah, god damn it. Pass error I, acquired by this bound fold many. Consider specifying the generic requirement. Cannot infer the type parameter E of this expression. So this is going to be F error. So this might be our problem then. So ref the and Rumster error. Would this maybe work? Ambiguous associated type. Ah, shit. So I want the U8 Rumster error. And that says that, wait, let's just read. Why is this still ambiguous? So U8 as example. Rumster error. Okay, definitely, I'm going down the wrong path. Okay. Why the hell is unwrapping so in hard? Let's just do this without unwrapping. So this is going to be result question mark, and then we can inline the variable back into position. And all of this crap is not working correctly. So we need to somehow still recognize the digits, which apparently we are failing to do. digit 1, map digit 1 on a string. So we've got new line, we've got dot, and I just want like the is digit parser. You know what? That's the time to actually look at the reference of someone who that I know actually uses that correctly, which is Crazy Thai Guy or Yoav. Advent of code. We'll try not to look at actual solutions, but only at parsing code. So let's look at, I don't know, probably any random day would use num and okay, so here we don't have numbers, so let's not use that. We do have theme. I don't know. I'm just basically looking at inputs and hoping to find numbers. Yeah, okay, so here we've got numbers. So let's see how do they actually do that. So they've got digit, number, integer. Okay, so how does it they do integers? Comp list. Oh, that's not good. Just want to pass numbers and into max expect, blah 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 blah. No. Okay, we've got numbers again. So we've got complete tag line ending, separated delimited parser. Interesting. I don't know what parser means here, but we'll see. And separated term. You can pass U8 like that. Why wasn't I aware of that? This seems like the obvious thing, but the fuck? U8. This doesn't seem to be correct. I mean, so delimited something U8 something. So this delimited thing is like doing the magic. We don't have any delimitation. We are just passing U8s. So can we just pass a U8 from stir? Would this work? No way in hell this works. Let's look at another day. U8. No U8s. Okay, definitely no strings here. Okay, numbers. Fold many, snafu terminated, line ending. Okay, so terminated line ending is a thing that I need to use, basically. So we've got let's look at that. So it's fold many. I don't know what snafu means, but probably it's something here. So yeah, snafu is just a fold many expression, and then you can just say terminated line ending. Wow. Okay, I was definitely not aware of that. Can we just say terminated? Not an alt, maybe? So Beetle tools. Interesting. That seems to be function a thing that I want to know about. So no alt. So this is like characters. Okay, so also here they're not converting things to numbers like like in the traditional sense, but we could do that. I mean, basically, we could say apparently char from num and that's going to be value empty. Feels like this is a different version, like things aren't looking the same. Complete, is it from complete? So non char branch factor complete char. Yeah. Okay, so recognize one character. This will return a node if there's not enough. Okay, that's very good. Then say that's mapping to point empty. Um, item as char map point empty, just to a value. And we've got, we don't need to like use the new line delimitation here. We can basically fold that directly. Yeah, okay, so I'm gonna just basically throw all this garbage away. Let's write a new parser that's cleaner and nicer, hopefully. So let input and something. We don't care about that something yet, and we want to fold many one. And we've got a branch, which well, we need to do something with this branch. And we want to collect things into our vec new. We need some closure which accumulates these. So we've got our super simple scaffolding. Now let's look at how do people actually pass things. So day, any kind of day. Okay, also lots of numbers. Fold many pass command. So pass command is dollar preceded by alt pass cd pass ls. Okay, that's very nice. So we've got result. Okay, so this U32. Okay, this is actually coming from character complete U8. I'm so angry that I haven't noticed that yet. Oh my god. As nom U8. Is that a thing? Okay, so god damn it. Yeah, so this is basically just a an unsigned. Okay, so this makes things so simpler. So we've got nom U8, which is going to, yeah, we are going to need to map things. So map this to empty, this to everything else to symbol, but we want map nom U8 to number n, and we said no new lines, so we need to terminate that. So how do we say terminated? Do we terminated first, second? So terminated alternatives of this, and thing is going to be just new line. So terminated new line. This is going to give us one row. So let's call that pass row then, because that's our thing. So let's do that. All of this is just a method called pass row. Awesome. and we need to give that. But that's definitely doesn't make any sense. Yeah, okay, so that's going to be a vector of points. That's very nice. And our input is going to be, well, this, but not quite, because we are going to fold that again. So we are going to now say pass many, and it's going to be fold many on pass row. So that's going to, actually, you know what? This is not going to be terminated. This is just going to be passing the actual row, not the thing. So fold many, just like, yeah, we have too many characters here. And that's going to be returning the input. Awesome. So pass schematic is now going to pass a terminated new line of pass row. That's going to be pass row. And our accumulator is going to be this, and this is going to be a vector of points. So this is our grid. Is this going to work? Please tell me that it is. And it says no new line. Yeah, it is correct. No new lines here. This one says pass one digit is, yeah, I don't care about pass one digit anymore. Apparently there is pass one digit built in. And we are missing the whole calling this thing. So yeah, call. Okay. And where many one is actually failing now. So where are we unwrapping now? Unwrap. So we are only unwrapping in the end, which is, I think, a good way to look at that. So we do have errors now, but we can try to figure out what went wrong now. So let's rerun this with a debugger. And let's look at the error, because we can do that, I hope. Memory view, threads and variables. No variables to show. Thing. Self 0, non-error. It says input ... many. So it does not like ... Why is that? So which of the many one is unhappy? Happy now. So this is actually going to be many 0, I think, because it might be called many 0. Yeah. Because we might not have more than one line. Okay. And our schematics and grids are now different, but we are getting somewhere. So this is going to be either an optional new line. So optional new line. And that's going to be still many one. And our tests are passing now. Okay, so that means we are now officially in business. Let's just run a quick check on our vectors here. So how would we handle the extra new line here? We can do that like that. So it's going to be opt new line. So that's going to be not a tuple, I think, basically. Of oh, you know what? This is just going to be an either a new line, and that means we are going to, if we have a preceding new line, we won't like be completely crazy, right? It's ugly. And it says, oh yeah, because pass row isn't actually returning, it's returning a vector of points, and this does not. So no thingy like that for us. You know what? We trimmed the preceding new line. There is none, and that means we are just happy. Okay, so let's continue on. We do have a board now, which has taken obviously too much time. We need to assert the length, or can we trust that? Yeah, we don't need to validate input. Let's just move on. So we've got our grid. So let input schematic be this. This should have passed everything. So we can assert input is empty string. Let's just do that quickly by using this test here. This says we are missing to do. Basically, this should crash on the to do, not on the input. And it says that input escapes function body here. What? Do we need to pass it like that? No, pass schematic. Borrow data escapes outside of function. That's actually true. Anyhow, change return type to error. Let's just run this with okay something. Input escapes. Why does input escape here? That's something. Where did this happen? Input escapes the function body here. The argument requires, yeah, so I'm definitely giving it, I'm lending it to the thing. Vec point. Okay, no need for the whole schematic shenanigans. This helpful? Okay, so mismatched types. It is true. We do have mismatching types now. Can remove all of the wrappers around this grid. Okay. What does that see that I don't? Clone. Clone everything until it works. Does not work. Shit. Um, so we've got parse schematic. It says borrowed data escapes outside of function. That means that in our parser, we are borrowing something and not returning it, basically. Let's think about that. So instead of push item, can we clone? Would this work? Does not. So this thing is going to, we are instantiating a new vector, we are pushing to it, and that's it. Then we'll something here. Maybe it's the trim. Let's remove the trim and let's see if things, no, trim does not influence that. So that's a string reference. Do we want to like borrow it or something? Can we? What the fuck? Trim clone. Okay, so it's all about the definition, it's not about the implementation. So let's look at that a little bit more thoroughly. So we've got our input. We are passing the schematic. We've got our input here. If we remove this assertion, this still works. Is it because of the unwrapping thing? Okay, so it was the unwrapping thing. Test schematics now is now broken because we haven't implemented it yet. Let's rerun everything automatically. Go past test as well. Can we rerun all? Awesome. So now we've got our tests running every time. We can run Clippy in the background. That could be nice. So Clippy, run linter on the fly. In the Rust font also, let's. Why is this not the default? I want the Rust formatter, not JetBrains formatter. Okay, so let's actually try to run the game. Apparently, it was the unwrapping, the question mark, basically. So yeah, I think that was the case, right? This won't compile now. Yeah. So apparently, this thing is fucking us over. So map error. I'm not sure why anyhow is now considered to be found invalid metadata. Okay. Yeah. Cannot determine macro resolution by simplifying the macro imports. Import use anyhow. Use anyhow. Okay, let's just move on. I'm way too obsessed with making things work, and I shouldn't. Like the wrong things to work. We've got our grid, so let's just do let this thing result be, it's already input which we don't care about, and our grid. And we don't need the schematic anymore, I think. Yeah, so we do need another grid, which is basically we need to mark all the neighborhoods of the symbol. So let's just do that. So let's do mark symbols. That's going to give us another, that's going to be our mask. That's very like, I don't feel comfortable with this right now. Yeah, sure, whatever. Okay, so function mark mask. It's going to get a grid, and we are going to return a vector of bools. Yeah, seems like the thing, but we want to mark the neighbors as well. So mark neighbors. Let's call that mark symbol neighbors. And let's Copilot do the thing where it actually, so yeah, this is definitely not the way to do this. So we need to basically clone the thing, which is just grid clone. And this is going to be mutable definitely. So we are going to iterate over this. So neighbors, wait, what? What is this X thing? Well, make mask. Yeah, so let mute mask equal to grid clone. Why is it unhappy? Just because we are missing X. Okay. So what's the way to iterate over this? So actually, this is where like chunking is actually nicer than actually doing the thing, but I don't know. Let's just look at that. So this should be the thing, but we need to not only do, yeah, so basically let's just explain Copilot what do we mean to do, which is dot 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 turns into everything is now simple. So yeah, and just to be perfectly clear, it's going to be this. Okay, so now that we've got an explanation also for ourselves and also for Copilot, and just to be perfectly aligned with everything, let's also smash a dollar here, and that is going to be this thing. Basically, okay, that's going to be all symbols, so it doesn't really matter. and we need to watch for the edges. Okay, so let's actually do this. So we've got grid, it's a enumerate, that's for rows, and this is our columns. So basically every point now we've got an XY coordinate, and this is going to be, how can we make this mutable? Because we need this mute row, and this is going to be not a, yeah, this is actually going to be maybe a mutable point. Let's think about that for a minute. So basically we've got our XY coordinates, and if the point is not simple, we can just move on. So let's just do that. If let well, not simple. If point is not simple, we continue. So now we can dedent everything one layer back and actually mark neighbors. Why is this correct? And compare. Match point because enum's rule, and it's going to be if it's point symbol, we are going to do something else, and otherwise, yeah. And now let's actually do this where we say mark symbol neighbors. That's going to be our mutable mask, and this needs to actually now happen. So fn this thing, and it says God forbid push. No, why would you do that? This is a mutable borrow, so we can just say xy equals symbol. And this is already a symbol, but sure. Let's just match on x and y and do this. So we've got basically 4 spots we want to, not 4, 8 spots where we need to mark things. So let's actually just do that. So top left, okay, yeah, let TL e grid get, so not grid get, but we want to basically set that point. Can we set, not set length? So TL is going to be we need to clip things. So let's just clip them. So first of all, let left be x. Oh, stop that crap. The minimum of x minus 1 and 0. So this is our left, right, oh, that's going to be our max of this thing, and we've got our top, bottom, and we are going to set all of these. Yeah, basically this is the way to go. This will horribly fail for probably like this will fail for because borrow checking, I would assume. Let's try to run that, and this will compile. No, it says make symbol grid. I can't believe this actually does not fail. I mean, wow. I would assume this would fail to compile. So this is going to the maximum between 0 and whatever this thing is. Oh, that's not going to be good. That needs to be as I size, because we need that be that's going to be we need that to basically we need to make sure this can be negative, and this also needs to be as I size. Oh, you know what? Maybe we can do this by saying I32 I size, and it now says, yeah, cannot contain. Okay, that's actually a very important catch. This needs to be I size. Or you know what? This needs to be U size, but we need to, yeah, basically we need to make sure this is actually safe. So I size. And row len -1 is also needs to be as I size. The maximum between 0 and -1, yeah. So everything here needs to be I size. I mean, okay, so we could do this more cleanly by not doing this iteration like that and just redeclaring x and y as I sizes for the timing. So let y I size. Yeah, that's very good. And also here as I size, as I size. And now we can insert yeah, sure, that's not the thing. I wanted another assertion, which is left, yeah. No, stop. So third, left greater equal than 0. Right smaller than row length. Yeah. So these are the assertions that make sure that we're not doing any crazy bounce thing. And it says that cannot use I size as index. We need U size. So which one is it now? So these ones are, yeah, so we need to cast them now. Once we've got our assertions working, we need to cast them back into U sizes. So, okay, all of this type gymnastics is basically we are doing some a lot of bit whittling, and then we are coming back to like the sanity world. Let's try to compile that, and it actually compiles, and it now panics or something. Error. It says input call backtrace blah 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 panicked on Rust part. Where does it panic? Line 155. It panics on the assert. Okay, that's very good. Let's debug the mask. debug dbg. So we are unwrapping earlier. So whose fault is that? Is this the unwrap? Like, where do we actually fail? So instead of this, let's actually unwrap here. So this will let us know. Where do we unwrap? We are unwrapping on this line. Okay, so panicked error. And what is the error value itself? Many1. Okay, so let's look at many1. So, ooh, I think I know exactly what the problem is. We've got too many white spaces. So let's fix that by not doing the whole white space thing. Because this is not like our input. Okay. Have we stopped panicking? We're still panicking. Many1. It. Let's look at our input of our parser. So this many1 thing is one of these is crashing. We don't know yet which. So, oh, wait. This is not the only character that's legal. So this is going to be dollars. We've seen more, right? What else have we seen here? So we've got slashes, percents, stars. Okay, so slash, percent, star should be working, I think, at this point. Let's see if we've got anything else. Plus. Yeah, we should probably say something that's like not white space, but I don't. I'm too lazy. And it's now panicking on what? Still on many1. So fold many. Let's actually run this in the debugger. And it's now saying unwrap here. But let's look at our input. Okay, so our input is this thing. If we go to our actual error, see code many1 and input this thing. So 467, is this the first input? 467 is the first input. So this has worked. Is this failing? Stop and rerun. That's actually, yeah, okay, so this parser is still working. So let's copy the first two lines from this and we make another test. Yeah. Paste that in. So we've got false. Yeah, okay. Good enough. Okay, so this is also failing. Very good. That means we can actually test that. So \n. Awesome. So let's figure out why is this crashing. You know what? We can actually, instead of keeping track of single digits, we can actually pass the full number, then keep track of the span, and then we can check if any of the things are in the span. This looks like we could solve this also with the dictionary, actually, if we think about that. We can just keep track of coordinates. So instead of this number, we can actually just use a U32. And instead of nom U8, we could say U32. This can account for all reasonable numbers. Actually, you know what? Let's look at the input here. So all numbers are quite small. Okay, nothing below that. So U32 is okay. And instead of yeah, so let's just use U32 now. And let's just call that rename function and its usages. So as U32 parser. This is hopefully going to consume. Is this actually consuming like the full number? I'm curious now. So U32 doc hidden will pass the number, can pass until the end of input. So complete version. Okay, so let's look at the test as digit 1, hex digit, oct digit. Where's the whole like U32 thing? Doc hidden. Are we not supposed to use that? I'm quite surprised. This should break the tests. Yeah, okay, so we are now breaking the tests intentionally because we are going to do one more crazy thing, which is to keep track of the length of things. So we've got I'm really unhappy with this. Really, really, really unhappy. We just want to like use hash maps and like store things and then just look up in the hash map. That might just be better instead of like doing the whole crazy parser thing. Feels like I will not be learning so much Rust, but it might be a better way to do this. So instead of all of this crap, could literally just comment this out, say, let symbols be, well, let's, how do we keep track of them? So we want symbols is going to be not a hash map. Hash map. Hash map of tuple of usize into a number. So KVS, what S? S is the random state. Okay, we don't need to do that. We don't need to care about that. So we've got let's call that yeah. So we've got basically a struct point is going to be x, y, and the number itself, and so we've got a point and yeah, no xy, just that, and we are pointing to something, and this something is going to just be a u32 for now, hash map new, and we could literally just, that's going to be mutable now, and we could initialize everything. So let's just input bytes, enumerate for each. So let x be, how get to 11, I don't know, but let's just not think about that. Okay, lines. And first of all, we probably want the length. Do we need that? We don't care about that because we are in like the world of everything's okay. So symbols, that's going to be if is if C is a this thing, this is now unhappy because it says found chal. Yeah, so can we, by the way, collect that instead of like can we construct the hash map in such a way? Anyhow, let's just do question mark and symbols insert. And it's now saying that the method insert does not exist on hash map, but the trait exists, but it's not satisfied. So convert to UFCS. So if this is, wait, can we just do this? And then insert symbols, insert. Mute. Then it says, yeah, hash map insert, and then it's unhappy because from okay, so we can do this now. Okay, that's very good. So we are inserting our point and our C, we don't care about that. But this is all of our points. So this can be a hash set though. Hash set, no value, just this thing. Okay, so this is our hash set. And we can pass these numbers now. So instead of so for each line we've got usize and line. Is that correct? Yeah, it is correct. Awesome. So let's now actually do the lookup. So we've got the same input. We are now iterating still over the lines. We are enumerating and then we say xy, and instead of that, we can say, so wait, line chars. So we don't need that anymore, I think. But we do want to find the numbers, and we need to find their location. So find numbers. We do want our mutable sum hash set. So let be so for each of these lines, we are going to do this, and so that's not correct, I think. Oh, that's actually very useful though, because that means that we could actually use isize. That's very, very useful. Where's this hash p? That's not going to be, if it's going to be signed, then we can also look at negative indices, but they're just not going to be in the map, which is very useful. So yeah, as size and as size. Okay, so we have now inserted everything correctly, I think. And yeah, let's do the actual lookups. So we've got our x and y, and we do not want to handle this, and we want to find all the beginnings of numbers. So let's actually, within each line, it should be quite simple. So let numbers be a fold of vectors. So actually, this is where like small parsing could help us. So let's try fold any one, and it's going to be, let's actually look at that. So we've got not terminated. Actually, it could be terminated by anything, so that's not going to, that we need our U32 parser. U32 parser. And we've got not just, we need to map that. So map parser. And we'd like to do something fancy about that. So we've got our number, but we do want to do more with that before we actually do anything. So first of all, yeah, this is going to be now not vec new. Basically, this is going to be, this can be literally a unit thing. So yeah, this is going to be ACC item, and oh yeah, this is not going to be, no, this is not a vector, but let's just can try to make this work. Anyhow, so we've got our number. We've got a y already, and this x is not really correct. So we need to recognize, but not consume. Or do we want to consume that? We want digit 1, because we want anything that's more than a digit. That's going to be a string, as far as I know. Ref the. And I do want the index. So in order for us to actually get the index, we do need math res, I think. Let's import that. So is this the thing? MapRes. That's a function G. And G is a function mutable with O1. O1 is probably not, no. So we don't get the input itself. So let's think about that. So it's not even fold. It's basically could be other things. So what else do we have in multi? Basically just many one. Yeah, that might be it. Okay, so not fold because we're not folding anything. We're just applying this thing many times. So let's try to figure out what do we want to apply many times. So we've got our line, which means we are going to apply it right here. And we want to recognize that result of at least one digit. And we want our string. And we definitely don't want to pass that. So this is not good enough because we actually want to do something with the index. So this does not leave us happy. How can we be sure what index are we doing? We can just iterate on our own and not think about that. But I do want like the whole summation thing. So let's try and figure this out. So we've got for each, and let's just write the closure. So we want lines, chars. Copilot is so happy to spew out so many characters. So we've got a line for each character, and we'd like to somehow skip. Maybe we could actually use this like in an actual for loop instead of doing this as an iterator in the per line case. So let's try this. And for xc in line chars enumerate. Let's think about that. So we want to recognize this line, like the substrings in this line, and then skip forward. So we could do this. We could say U32 parser on line. And that will give us. Ooh, that might be actually good. So we could try to do this. So while let sum x in something. I'm not sure if sum is the actual thing that we'll use, but so this U32 parser will actually give us something that's definitely not this thing. So let's actually try. So we got while let's input and a number. So this will advance every time. Or is it? No, because it's going to fail on anything that's not U30. Hmm. Indexing into arrays is so much nicer than actually like doing the iterations sometimes. Um, so we might want to say alt on U32 parser or any character. What will this give us? So you get one line every time. So expected a function found this thing. Okay, so we've got our alt things. So it might be any character or a U32. Each one of these is actually will give us so while let input equals this thing. And we need to like look up for the neighbors yet, so we need to figure this one out. So our input length right now. So first of all, this needs to be line. This is basically we are consuming the line now. So while let line do something, and we've got our line comma something. So this is going to be line and number. And this a number? Not necessarily a number. It might be any character, basically. So we need to, first of all, match on number. And if it's going to be U32. Okay, so this is not actually inferring correctly, or what are we missing? This needs to be a U32 or one char. So 32 or char. Can we say that? How's this alt thing? It's going to return, give us like you know what? DBG number and DBG line. Let's just run that and let's figure this out. And it says required char to implement input at token. Um, so let's this is HR. The trait input length is not implementable char. So we do need actual like length for that. It needs to be like more than one. Can we actually, instead of that, filter? Because we are enumerating on them, so we could filter. So filter map. Okay, that's actually the one that we're aiming for now. I mean, yeah, filter map, sure. And here we've got XC, pack that. And we want to say we want all of these. And we want to apply that. No, that's not going to work. Still. And crap. So for each of them, instead of that, let's. How can we make that? How can we say cast that into a string reference? Can we just literally do this? Let me as stir ref c to string as the. Wow. A lot of type gymnastics. It says this returns an option and accepts could return. Wait, I see. So this is where we need to actually filter map. So you know what? We could literally say if it's okay. Is okay and do this thing. Okay. And it says unused return value of let. Okay. I mean, it is a for each, so we don't care about that. So this should be okay, maybe. Any char expected the functions that returns result blah blah, and it does not. So that's why using the U32 parser by itself is kind of annoying, because it's really not playing nicely with all the others. Wait, is that in the right place? Yeah. Okay, so instead of like mapping that, we could do this. So we could say map this thing, and we could say could just have ourselves an enum of maybe number. Oh, actually, you know what? Option number, basically. So that's going to be n as some n and any char as none. Okay, so that's an optional number now. So option U32. Just we need to say that, yeah, with and this is going to be our ref star. And why is it angry at me? Because we do this and this is unhappy now. Okay, so cannot use let expressions, add let chain feature. Cool, let's add this feature. I don't care if it's unstable, let's just do this. So we've got our map parser, which is passing this and gives us sum in, or it passes any char, because that was the whole point, and gives us none. And is this understanding me? I don't think so. Not really. We've got our line while let. So first of all, let's try to compile that and let's see what's going on. It says y line result option that this thing. Cannot use question mark operator in a closure that returns unit. Okay. Or is it because of this thing? Yeah, let's just unwrap. Fuck that shit. Oh no, no unwraps on the num. Question mark. And so it's we could say is okay and okay, so that might be nicer maybe. Or else unit. So or else just do this. Can we return unit, or do we need that to be again the same, different? Oh, so that needs to be like the whole okay, reference string none. And this now claims to be found blah 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 blah. None. Refster option 232. Selected option U32, found result option. We need this, just I see. So this is kind of annoying. Ba, 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 ba. So firstly, like, I want these to be a little bit nicer to me. So we've got map parser, this one and this one. Why can't they just stay on different lines? So this is okay. So let's just do filter map, I guess. That will let us wrap around it, maybe. Let's just take this, remove all of this crap, and we can now try while let thing and our sum equals thing. That's our thing, and sum, and that's just going to be while let okay line and reference a string. That's not going to be not true. Oh wait, what? This is actually in the wrong order that not in the order that I think about, but expected net found option. What? We need to call that online and unwrap and oh my god. Why is this so terrible? Okay, so first of all, I think let's actually just use a function for that. So fn maybe number. That's just going to be let maybe number equals this thing when it's not applied. This is our parcel. So parse optional number. So let's open up a closure again. We are now filtering and mapping over all of that. So we've got our line, and that is going to be we need to basically ratchet our way through that. So while let something, which I don't know what it is yet, line. Found result. Wait. Expected option, found result. Can we degrade that into some? Okay, let's just move very, very slowly. So we've got this thing. Cannot do this because in filter map we cannot do any of that. Are we afraid this will error out? This will error out when we we run out of input. So this must be handled in some sense. This, by the way, is that's going to be line and our AB number. Um, 232. Oh, that's nice. Okay, so can match on that. So let's try that maybe. So match on this thing. And then it's going to be either okay. And if it's input n, then we're doing that. Otherwise, none. I mean, we could basically just tag along everything. So let's actually, maybe let's consider that. This might be the thing that we want to do. So we are, wow, Rust is really, really cheap with the amount of closures that it does. I want a let statement. Let something. And now, will you believe me, Linter, that I want another level of hierarchy? Just removed my assignment. So nice. Okay, there it is. Let's figure this out. So filter map pass optional number. So let mute input equals line clone and while match the other way a thing to do. I mean, we could literally just loop. Let's just loop. Yeah, let's loop. Okay, so we've got this thing in our loop. We will do this. So loop put, we are going to match on that. And that is going to be a new forward thing. And this is going to basically just be, input is just going to be forward. And borrowing, that's okay. We are breaking on air. And we are missing something probably. Found unit. So expected option found unit. Let's just do Why is it unused filter map? Yeah, I don't care about that. Let's do that. Let's do this. We've got our line. Within each line, we are forwarding, pushing forward some every time. And this is, let's call that maybe n. This is still an option. This is intentional. First of all, let x be line length minus forward length. That's great. And match on maybe n. Maybe. I could only type if it's sum n, then we want to do something about that, not symbols insert, but we would want to look up and see if it has neighbors. So if has neighbors, that's going to be our function call, and if has neighbors, then we are going to sum that, some thing, otherwise we don't do anything. Why is match n? None. In case of none, we are doing literally nothing. So is that true? If it's none, then we don't do anything. So sum n, arrow to this thing. Okay, so we've got some neighbors. Okay, if has neighbors. Now, what would we need to know if it has neighbors or not? We could see this. So we've got our sum. So we need to basically plus n our sum. That's okay. But we do need x, y symbols and the number itself. So we do need n. Why would we need n? Because if it's a number, then we need to know its length. So how would we do this correctly? Because we do want, yeah, I guess we could just do that. So let's update our function. So first of all, n, let n length be n into string len. So I mean, this is buggy in some sense, but so we've got left. Yeah, we don't need to actually do any subtractions now because this can actually be isize. Let's just convert that into isizes. As isize and as isize. And why is it unhappy? It says this is returning a bool. I mean, at least we claim it is. If is missing an else clause, is expected option found unit. Add else branch, none. So match arms. Cool. So first of all, yeah, just input equals forward, and this just go to none. we can just do this. Okay, that's good. And it says n moved found usize. That's okay. And now let's look at the needles. We've got a hash set, we've got this thing, and we need to do this. So we need a vector of lookups. So lookups is just going to be a vec of a lot of things. So x and y are just the things that we need to look up for. So we need the combinations of all the things. I mean, we could optimize, but let's just do this. Like let's collect everything basically. So we've got for I in 0 and length. Wait, let mute lookups vec of that's going to be -1 -1 should be 9 spots. Let's verify that. So we've got that is probably incorrect. Oh, that is correct. Where's the 0 0 case here? 0 1 1 1. Okay, so that moves. So we've got everything from -1 to +1. That's very good. This is going to be vec of I size, and it is unhappy because it found the vec of first of all I size and I size. Yeah, that's very good. Okay, so we've got our moves, and we've got we need to basically ask like where all of the points. So we need to say we need to fold this range. We need to do string. Okay. Oh, we could actually do that. That's very nice. So we could say to string enumerate stars enumerate. That will give us the indices. So wait, this is actually not mutable. This is static. And let lookups be let mute lookups be a vector of things. This vector is going to be just an empty vector. We are going to push things into it in a minute. Actually, back here, and I won't keep you very curious. It's going to be this thing, of course. Actually, we could make that into a hash map and a hash set, and that means we can dedupe before we do the lookups. So hash set of these points, and that's going to be hash set new, and for each we don't care about the character itself. We just want to lookups to do all the lookups basically. So moves iter for each dxdy So this is just going to be, yeah, so basically y. There is no I. I mean x plus I has I size. So this is going to be a lookups of I size and I size. And it says expected return bool found unit. And this is just not yet ready. It says dx as I size. We don't need that, do we? Right? Yeah. So we've got, this is basically all of our offsets. Yeah, so we've got our hash sets and can say now lookups any xy contains. Okay, so I think that is our Boolean now. So for each x, we are checking if it has neighbors. If it does, yeah, we don't need the end length anymore because we are dynamically calculating that by iterating and just adding the offset. And yeah, okay, so if it has neighbors, then we are running that, and let's run the tests. And it says a lot of stuff. Trait bounds, input error, not satisfied. Why is this ref still? Firstly, we can actually make that into, let's extract that into a function. I don't like this. So let's extract this into a function. So fn maybe number, that's going to do this thing. And going to be consuming everything. Yeah, so that's going to be an option u32, and maybe number is going to do this. And it says is a as not, oh shit. So let's just match on that because, well, can. Okay, so okay, I don't care, then do this. Otherwise, do nothing. And that is a for each loop. And it says found bool. Why is it finding a boolean? Okay. Cannot infer type parameter L. But we don't care about the error. Um, so we've got our character and would literally go with like the dumbest thing, which is to say, yeah, this. Exactly this. None T. So we don't need to filter map this. This could be a for each, right? Then we just say this thing, everything returns unit, and we don't care. Okay, so we don't care about this schematic parser anymore because we are not using that. We need to return the sum, which we haven't done yet. So let's actually do that. In our thing, let's just do sum to string. We have a different answer, but we have an answer, which is very good because we can now get rid of all this crappy parsing code, which I hate. We've got just this thing and with a lot of imports, maybe number, that's a thing that we actually use, and remove a lot of crap. So some details omitted, and that doesn't really matter. Okay, we've got some answer which is incorrect. So let's debug that very, very slowly now. But we do have something that's like running. So firstly, is this actually dotting everything that we need? Do we have any other symbols that we know of that are not in this grid? Let's see. Count, firstly. So that might affect a lot of things. And our answer is the same. We could, first of all, we can test the hash map first, like the hash set, because this is actually a thing. So let's track that into build symbols. Awesome. So build symbols is can borrow a string and run this. Okay, so let's test out build symbols and then we'll figure out if we need to fix things. So test and test build symbols, and we need, yeah, I think this is good enough. So let's actually do this a little bit cleaner. You know what? Let's actually we can start very, very small. So we've got star star dot new line dot dot star new line dot dot star. Okay, that's very small input. We could toString that, sure. And we can say build symbols, and we can assert on whatever we've got here, which should be, first of all, 4 symbols, and assert symbols contains. Yeah, that is correct. So x0, x1, x2, 1, and x2, 2. Okay, let's run the test. Okay, so our map builder seems to be okay. Let's actually expand that with maybe more symbols now, just to be sure. So we've got dollar, percent, pound. Okay, so the symbol map seems to be working. Let's just make sure that assert not contains on -2 or -1. Okay, yeah, sanity, basic sanity. So we've got our symbols. We basically build this out and we return a new immutable map. That's very nice. So our symbols are now borrowed here, and we just ask if it has neighbors. So this has neighbors is now the next test that we should probably write. We've got function test has neighbors. So we've got our map, and we need to ask about this number. Actually, we need a bigger map. So let's actually do this correctly. So we've got this thing. Okay, so this is our map. Okay, let's verify. Okay, so we've got 1, 2, and let's have 3 and 45, and we've got 1 star. So first of all, let's actually assert that we know that this one has 1 symbol, which is going to be on 2, 2. And once we've got that, we need to assert as neighbors. 1, 2, 5. That's going to be. Oh, that's actually going to be. That's incorrect. That's going to be 45. Our number and the coordinates are going to be x0, y2, and the number 12 is going to be on coordinates 0, 0, and it's not going to have any neighbors. And we do have the number 3, which is 0, 2, 1, 2. It is, oh, sorry, 2, 1, and number 3, and it does not have neighbors. It has neighbors. So let's actually test that. This test fails. Ooh, which one? This assertion. So first of all, let's actually verify that. So we've got 2, 1 symbols. And why does this fail? So the number 3 in the position column 2, row 1. Okay, so let's debug that. So we've got our moves, which is going to be 0, 0, -1, -1, -1. Da, 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 da. Okay, all of these moves look okay. We can assert, or we do the lookups. Lookups That length must be greater or equal than 9. This assertion hopefully does not fail. If it does, we're in trouble. Okay. Ooh, unused variable dy. Ooh, that's the thing. Our dy is going to be, yeah, let y plus dy. That is definitely going to be a lot of help. Okay. Back to trying this. Left. So we are still not summing enough things. But our tests are now a little bit better. What were we missing? So we need to move plus or minus dy. Are we doing that correctly? Let's look into the has neighbors function and just make sure, like, let's actually cover more edges. So let's add more dots, and let's add another UV of length 2, and we need also, that's going to be x3, y0. Are we running? We're not running. So let's run all of these tests. Test build symbols. Oh. So test build symbols is going to be of length. Oh shit! Definitely. Assertion. Good. Okay. So this is still working. We should definitely encapsulate like the point with the location in one enum, but I'm too lazy now. Let's run that. So this one is now failing. Let's see. What is this? Test has neighbors. I feel like Copilot has auto-completed some things that I haven't tried for it to complete. What is this? So test has neighbors. What happened here? I feel like things have gotten mixed up somehow in the tests, but oh my god, wasting so much time on Rust. Let's see. Yeah, this should have been build map. That symbols gains. I'm not sure what happened to the tests. Let's just rewrite that. So in this case, our symbols table is going to contain exactly these things, no neighbor assertions. This is just to test real symbols. Then we need to test has neighbors. We can take the same string. We can toString that, okay, and first of all, we can, okay, so definitely Copilot has not understood the API, and that's okay because this is a confusing API. But the number 12 at position 0, 0 has no neighbors. The number 3 at position not 0, 0, but in position 2, 1 has neighbors. And the number if it Copilot is bullshitting us. Yeah, this is 0, 2. And it has neighbors. Okay, so this thing is now tested, and we are still failing our actual test, which is the game. Oh, first of all, oh, this might be a thing. So yeah, no new lines here. And let's actually look at the next bit of code that needs to be tested. So has neighbors is kind of looks okay. This thing looks okay. Oh, simple map builder. And we need to extract all the maybe numbers and add them to the right places, place them in the right locations. So instead of actually doing this, let's collect that into a thing. So instead of, we can like copy this struct, and instead of point with value blah blah, let's do this. Let's call that number, and this number has a value, has a position x and y. So our number now, let's collect it. So find numbers. So let numbers be all of that. This is now, so instead of for each, we need to filter map. And instead of doing this whole thing, we just want to say match maybe number. And if it's number, we just want to do something about that. So let's match like that. Let's move this forward. Let's more all of the inside. And done. And is going to be some number, and it claims that says expected option found option number. Expected unit found option number. Wait, does it expect unit? Look at that for a minute. First of all, maybe n unwrap. No, that's not good. Yeah, okay, so first of all, match maybe n. So match on maybe n, some n, then something, otherwise none. And some number. And all of that is Why is it expecting unit though? Are we missing a break statement? We probably are. So this is a loop. Oh shit, the loop. Need to return out of this loop. So return and return, return. Okay. There's the return keyword and the auto match. Okay, sure. We can also return this lift return. Wow, that's much cleaner. Wait, but this returns. Oh, so this needs to be continue. This do not return yet. And let's see. Um, I want to collect that somehow. Go vector. So let's do that. That's going to be collect. And let's figure this thing out. Well, you know what? Maybe we could. So as long as this is okay, we just need to collect this. Return sum and sum. And no, so we can't return sum yet. We need to actually do something. So all of this loop needs to be collected internally and then we can like flatten it out. So this is not going to work like that. Okay, so this is going to be let numbers be vec new. We are going to push on these numbers into that. So instead of uh, uh, filter, it's just going to be back to for each. And this thing is going to be pushed. So numbers going to be node and numbers insert number. This needs to be mutable. This method takes 2 arguments, but 1 argument was supplied. Mute self index element. Oh, so it's push. Yeah. And this needs to be empty. Okay. Okay, so find numbers. So this is also splittable now into a method which we'll call find numbers. And we do need to return these numbers because we will need to reference. So at the end of this to return numbers. Back of numbers. Yeah. Let numbers equals this, and we can say now numbers theta filter map, and if has neighbors, then some value, otherwise none, then dot sum. That is going to be our let sum. This, we don't need this mutable one, and sum to string. Has neighbors n, x, y, blah, 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 blah. Yeah, seems cleaner. It says sum needs usize, sure. It says divided by bound vec number. Usize cannot be made for summing iterators of element u32. Ooh. So n value as usize. Okay, this is definitely infinite looping. So let's look at our infinite loop then. So while let if put empty break. And our algorithm is still the same, but we are now a little bit more, we can now we can attempt to test this find numbers thing, and we'll see if we've got any errors. So let's test find numbers. This needs to be and our numbers can literally assert what order things are happening. This would be a lot stricter. We've got 3 numbers, and that they're going to be numbers that equal. Yeah. Okay, so let's look at the numbers and actually compare what went wrong. So firstly, which assertion is actually flying? Let's verify this is not like failing on like some. Okay, so the count is correct. Now let's actually compare the numbers. So we've got value x, y thing, and we are getting x. Okay, I think I figured it out. And I think we are finding, like, we are computing x wrong, which needs to be line minus forward len minus the number. So yeah, okay. So firstly, we can create this here, and we need n to string length. And now we've got everything working. Awesome. So let's run that on the actual input, shall we? Yeah, so our input is going to be new file day3 part1 .txt, obviously. And let's run that. So let's cd back into dev. advent of code 23 and cargo run day 3 part 1. It says let chains unused, and it says that number unused error could not compile due to error. So first of all, we're not actually using this feature, so we could go back to actually not using it. So let's, where's the feature? Where is it declared? So no let chains, yeah, that's okay. And anything else that we need? Warn dead code. This I don't care about. So we've got our output, which is going to be a number, and let's plug that into advent of code. And that's not the right answer. Our answer is too low. This is the point where reading the riddle again is going to make us a lot happier. So what is the sum of all the number parts in the engine schematic? And any number adjacent to a symbol. So if it has any symbol adjacent to it, then we are happy. We need to also check the diagonals, right? Yeah, even diagonally. So firstly, do we need to do anything fancy like, let's just add a new line. I don't know if this will actually do anything. Let's just run that and see if it changes the output. It does not. Okay, so sanity restored. Maybe the symbols that I have not considered, like currently an ampersand was a symbol. Ooh, an @ symbol. So, okay, seems like this would be the least scalable thing here. Let's run that again. And our output is a little bit higher. We might have other symbols here. Let's try to submit that. That's not the right answer. It's still too low. Okay, so I see more symbols, like the equal sign. I mean, we could be a little bit, obviously, I could be less lazy and actually like see what else can we need to find here, but I'm just gonna do this the dumb way. You gave an answer too recently. You have to wait. You have 29 seconds left. Wait. Oh, that's very nice of you. 14 seconds. That's not the right answer. It's still too low. Okay, so we probably just have more symbols that are just not covered by my pattern matching. So let's figure out what's the best way to do this. We just need to say everything that's not basically not a dot and not a digit. So we've got is digit wait before the thing. So we've got that. So match not is digit C. Can we negative match thing? Is that a thing? So, or you know what? So we can do this. We can say dot goes to nothing. Um, um, literally 1, 2, 3, 4, 5, 6, 7, 8, 9 also go to nothing. And otherwise, it's a symbol. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are there any zeros? Probably there are, right? Let's just also add 0 just in case. Stupid thing to skip on, but yeah. Let's run the tests again. Nothing should break. Okay. And let's rerun that on our thingy thing. And let's see if our answer is changed. Yeah, wow, it's a bit higher. Quite higher. Return. Let's resubmit that. 1 gold star. Okay, so yeah, our solution is working. That's very nice. Part 2. I have less patience, of course, but we will power through this. We are 3.5 hours into this. So the engineer finds the missing part and installs the engine. As the engine springs into life, you jump in the closet closest to the gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola has a phone labeled help. So you pick it up, and the engineer answers. Oh, by the way, we could commit that. We do have everything working, so yeah, day part 1 solution work. So part 2. Pick it up, and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going to slowly, so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. The one of the gears in the engine is wrong. A gear is a star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. Okay, so this time you need to find the gear ratio of every gear, add them all up, so the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. So we need there are 2 gears, yeah, so 755 and 598 and 467 and 35. Yeah. Okay, so part 2. Might re-architecture for tomorrow. I might just change the output by basically outputting 2 strings, which are the combined solutions, and then we won't need to worry about that. So first of all, let's just copy our input. And our output now needs to be copied as well. So part 2, let's paste part 1 in. And let's add this to our input. Part 2. And within day 3, we need to say part 1, part 2. Okay. So in order for this to work, what would we need? We need to find all the gears. So first of all, instead of build symbols, let's just build gears only, because, well, that's the only thing we need for this map right now. So we need another variant of this where we just replace. So yeah, basically star. Okay, so we've got gears. We are missing this. This is now disaster. This is going to be called build gears. And our build gears is going to accept, let's just test it very quickly. So hash test build gears. And it's going to contain only the 0.22. That is correct. I mean, this is just the star map, actually. This is not the gears yet. This is just a star map. And let's call that also stars, because we haven't ruled out anything that has more than one neighbor. And instead of this star map, we can actually instead of hash set, let's do a hash map with a u size as a count. This is going to be a hash map, and our default is going to be, well, 0, because we are not counted. We haven't counted that yet. So our star map is now containing the same, like this test should still run. Let's actually run the tests now. It says expected hash set found hash map. And why is that? Because we are returning the wrong thing. Okay, so our star map should now test. Use the import on part 1, we don't care about that. It says stars contains, no method contains. Interesting. Contains key. Okay, so we are now running, what's the running part 1 tests? Why is that? We ought to be running part 2 tests. So part 2 tests. That's very good. And we can now change the test instead of the sum. We can change that into, well, test. That's going to be here's sum. And the input that they claimed is going to be, that's going to add up to this number. So yeah, that's now going to obviously fail. And let's just run that and see that we have a failing test. We do. We also have another failing test. Here's some. Yeah, okay. So let's actually update the thing. So we've got our neighbors, which is very good, I think. But but we are going to basically, this is now not going to work. This needs to be a hash map of this to usize. So yeah, we have definitely stored things like quite the opposite way around, but sure. Basically, if we have neighbors, for each, where's our symbols? Yeah, so symbols contains key. So instead of iterating over that, so this is now going to be update neighbors. Lookups. We are going, for each word, we are going to do the lookup exactly once for each cell. That was very important. And for that things we need to, for this we need to say we are no longer iterating on any. We are just basically doing a for each because we are just updating the other thing, which is just making sure that we haven't had any logic here. No logic at all. So this is basically just, yeah. So for each lookup, we are going to, we have our point P. And within that, we are going to say lookups, not lookups, sorry, symbols. We are going to if contains key, contains key P. Oh, can we actually do something like symbols get key value? I want like mutable borrow basically. This, by the way, is supposed to be symbols and raw entry keys iter filter map to owned borrow clone deref. Increment dot entry. Okay. And modify mute size. Okay, seems expected bool found. Yeah, this is going to definitely be unit now. Okay, so we are going to +1 every time we are doing this. Is this the way to mutate? No. Okay, so apparently this thing. Okay, so entry and modify this thing. Okay. I think we can basically just be P, right? This is P. Expected reference. Does P clone work? Because why is this not the thing? Oh, because I just needed to basically say and PXY. Yeah. Okay. This looks better. So if this entry is here, then we are bumping it. Now we just need to, let's call that here's. So update neighbors is not called yet because we don't have this function in this area. So let's go back to our actual game. Where is it? Build star map, build symbols. Yeah, no build symbols anymore. Using it. And find numbers. This is actually useful. Are using it. Right? Duplicate code fragment. That's okay. I don't care about duplicate code fragments at this point. And we just say update neighbors. And it says that filter map is not happy because just say because we're not summing anything anymore. That's going to be let. Oh, actually, we do need to sum things. Sorry, that's not true. We need to sum neighbors. So this is going to. So instead of actually, oh, that might be nicer thing to do. So first of all, let's call that build our map. Now all of our maybe here's. And we found all the numbers, which we basically can do that regardless of the input. And we have now updated all of our gears based on the numbers. So we can actually let's just call that map. It's a map. And let's just do that. So n update neighbors. And that's going to be empty. So we have now mutated maybe gears. We know everything about that. But instead of actually just modifying that and just adding the count, we already know the number. So let's actually do this even better, which is to say, instead of doing this lookup with it not knowing the value, we already know it. So we can just put it here. So our entry is going to be not only usize, it's actually going to be let's have an enum here. So not an enum, struct. And the struct has the neighbors. That's a usize. And that's going to be our here. And our value is going to be also usize because we are going to multiply things together. And this is now going to be a gear, not just any hash map. Also, this build symbols thing obviously does not exist anymore. And this build star map needs to also return this kind of thing. And in order for us to return that, we need to actually have a empty gear. Yeah. And this gear now can actually mutate things inside it, which is, yeah, exactly. So we are going to increment the non-neighbors, and instead of that, we are going to multiply them. So that's going to be by n as usize, because we've got our number here. And that is now, is that the instruction, right? It's going to be the product. Yeah, that's the product of them. So we are basically going to chain the products of everything. Then we are going to, once we've got that, so now that we've got on maybe gears, we can filter them out. So let sum the maybe gears iter filter num neighbors equal 2. And we map on the value, sum as usize and sum to string. And we can run that, and it claims that we are making it unhappy. Does not implement the copy trait. We definitely want to borrow and mutate. So, oh wait, that's our points which we don't care about because we're only implementing. We only care about the neighbors. Can we do this? So that's our p from copy. And it's missing one mute thing. Is that true? Not referenced by borrowed in a mutable state. Why is this mutable though? Lookups. It's not mutable anymore. So can we like mutate on the spot here? Make lookups mutable. Let lookups be own self. This is now not mutable. It says mute gears hash map. Oh, wait. Oh, so the gears are not mutable. Here is a reference. So the data it refers to cannot be borrowed as a mutable state. So it needs to be just a mutable hash map like that, passed around. That's going to be definitely this. But I do want to borrow and then return it back. So this needs to be a mutable reference. Apply fix. Consider removing the borrow. Cannot borrow our gears as it's behind the reference. Oh, I see. Okay, so now I understand that I'm just placing the mute in the wrong place. Yeah, this is a mutable borrow now. Then here we can say this, and this needs to be now arguments to this function are incorrect. Found reference, maybe gears. So that needs to be mutable. Let mute. And it still is angry at me. Expected mute hashmap p gear. Found mute hashmap p gear. Wait, oh, what? Okay, so is that the way to do this? Can I just pass it in and that would work? Change parameter type and function. No, that's good. So yeah, I'm going to mutably borrow. Wow, this is like shaming me for doing this. Hi, please. And now we are crashing. That's very good. So first of all, let's actually dbg our maybe gears length. That's a good place to start. And we've got 3. Is that correct? That is not correct. We should be getting a, oh, wait, maybe gears is, okay, we do have 3 stars. So let's maybe actually count the actual gears. So let gears be maybe gears filter number neighbors, and that's going to be exactly this one. Why is this a function that returns a function that returns blah 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 blah? I just want maybe gears iter filter collect. Okay, so gears are now unknown. Interesting. Collect gear. Vec of gear. No. Collect into, no, not into. Oh, that's a hash map, right? Oh, wait. Maybe gears is a hash map. We don't care about the locations anymore at this point. So we can literally filter map. Okay, so filter map might be the thing that we want to do here. That means that we say, let's just wrap that here, otherwise nothing. And we can collect that into a vec of gears. This collect say that cannot be built from iterator reference to gear. Oh, no. Reference. Okay, vec of gear. Okay, so now we've got gears. Let's look at them. So dbg gears. Let's implement debug and whatever whatnot. And it claims that this needs to be something, not move out of a shared reference. Okay. And let's look, gears are empty. That's not good. Means that our update neighbors function is not doing the thing that it's supposed to do. And we have not tested it. So why should it? Functions that you don't test aren't working. So we are giving this a coordinate and a number and a map of gears. And within this map of gears, haven't asserted this actually works. So for each lookup, we are going to, first of all, let's actually let entry be this thing. And dbg entry. Okay, this is going to spam the thing. No, it's not going to spam the thing apparently. the fact that it's not spamming, that's actually worrying. So, entry. Entry and modify. So this lookup. Is this actually being called? Map n on numbers. Third number len greater than 0. Okay, so we have numbers, we have gears, and we are mapping over this thing, and we are updating the neighbors. First of all, let's actually debug the numbers. So this thing is not being called because we are seeing this, right? Numbers length, yeah, 10. So what the hell? Okay, so we've got our numbers and things working. So map, we've got our number, and before we actually do the thing, let's actually plug here. And we don't need this anymore. Okay, so this function is definitely not being called. So numbers, iter, for each. Just like optimize the way. For each n, please do side effects. Okay, so this is now a for each, and this should be okay. Way more crap going on. Okay, so mapping over unit basically lets Rust do whatever it wants. So we don't need this anymore, and we probably don't need a lot more of the asserts. So test gear sum, still 0. Let's actually run that. Let's look very closely again on all of the things that are happening here. So let's actually print the map. So we've got maybe gears and we've got gears. So let's run that. It says ref value moved here, and that's correct. We need to just borrow and change that. Okay, so we've got maybe gears, we've got 0.34, value 0, and we've got, okay, so first of all, that is definitely not working as we expected to, and that is because, well, it needs to be 1 because it's a product. So our default value needs to be 1. I mean, we could also say something. Yeah, okay, sure, that's good enough. Where's the insert? Yeah, so value 1, num neighbors 0. And our tests now pass. Awesome. So let's run that over the input and see if we actually get things working. So Part 2. We run that, we see a lot of prints, and then, yeah, we forgot to turn off some debug prints, so dbg definitely can be turned off. All these debug prints, we don't need this anymore, even. And do we have any more dbg prints? No. And our output is huge. We submit that, and we get 1 gold star. That's very nice. Okay, so we are done for today. See you maybe tomorrow, maybe in the weekend when I have a little bit more time, because this is consuming a lot of my time, and I do have a day job. So see you for now. Bye bye.